Hi.
Hey.
Looks like we got you. Just waiting on
Okay.
me.
Did we get Kenzie yet?
No. I don't know. She says she's not getting the emails, but I'm not sure why.
I was just slow this morning, so sorry.
No, you're fine.
Can you still see me?
Yeah.
Hmm.
I'm gonna go grab some headphones real quick.
Okay.
Okay, we got Mackenzie now. Cool. Can you hear us, Mackenzie?
Yes, I can.
Okay. Cool. Guess we're ready to go then.
Good job.
Okay. So last time we said that Teresa would lead this lesson for us, so we'll let Teresa lead what we're gonna do today.
Awesome. Well, I'm just logging into iLearn really quick, so
Okay.
1 second.
And then Mackenzie, will you do it next time?
Mm-hmm.
Cool.
Okay, I'm just about there. Okay, so did everybody have a chance to look at the prep assignment?
I did, yep.
Okay. And do you guys feel good about it? You feel understand it and stuff?
Mm-hmm.
Yeah, I'm good with it.
Okay, so we're going to do part 2, which is the 4-sided die. And so we just have to make a chart. And it needs to have 1, 2, 3, probably it ends up having four columns, right?
Uh-huh.
A value account, a value times the proportion, and then number 6, we need to know what the standard deviation is. So we'll need that one too.
Okay.
So we make that chart. And then we have value, account, value times. Okay. So the first, the X is the variables are 1, 2, 3, and 4, right?
Right.
First column we have 1, 2, 3, 4. The second column, so the probability of the die are going to be 1 out of 4, right? So every 1 out of 4. So that's 1 out of 4 equals 0.25 on each of them.
Yep.
Okay. Okay, so for the value times the proportion, we do x times p to the x, which is just 1 times 0.25. So we need to do those calculations.
Okay.
1 times 0.25 is 0.25.
Then I just did 2 times 25 is 0.50.
Okay, good. And then 3 times 0.25,
0.75.
0.75. And then 4 times 0.25 is 1.
1.
So then we add those all together and we get
2.5.
2.5.
2.5. So that's our bottom column is 2.5 on that.
So that's the answer for 5, right?
That's the answer for 5 is 2.5.
Yep, that's the mean. Okay.
And then we need to do the last column is x, which is the value, minus the answer, which is, what's that called? The standard.
That's the mean, yeah.
Mean, standard, the sample mean.
Yep.
Squared times the probability. So we're going to go, on this first one, we're going to go 1 minus 2.5 squared times 0.25.
Okay.
And then we'll do that on all of them. 2 minus 2.5 squared times 0.25. So 1 minus 0.25 equals, and then squared, and then times 0.25. Okay, so on the first one, oh, I didn't do it right. I'm going to try it again.
Did you get 0.5625?
I did, yeah.
Equals times. I got point. Okay, what did you guys get?
0.5625.
Right. Okay, so the next one then would be 2 minus 2.5 equals, square it, times 0.25. And I got 0.0625.
Yep.
Okay. And then 3 minus 2.5 equals, squared it, times 0.25. And then the same thing for the third one. So 0.0625.
Yeah.
And then
the fourth will be 0.5625.
Right. So then we add those all up. And has anybody done that yet?
Yeah.
1.25.
What do you got?
1.25.
1.25. So that's the variance. And so to get the standard deviation, we just take the square root of the variance.
Okay.
So we go 1.25 and then just do the square root of it. And then we have 1.118 as the standard deviation
Perfect.
of the discrete random variable. So that is the answer for that. So it's 1.118 is that answer. So basically, it's kind of the same table we did before,
Yeah.
but this is just a table for specifically the discrete random variable. So,
Cool.
so anyway.
That works. Should we start the quiz?
Let's do it.
Okay.
Okay. Complete the following individual. True. True. Okay, so number 3. No, give all your probability answers as decimals. For example, 0.1234, don't give probabilities as percents. Okay, so human blood could be classified into 1 of 4 basic types, O, A, B, and AB. The proportion of people in the population in the United States with each of these blood types is summarized by the following table. Boy, that's little for me. Okay. Use this data to answer the following questions. The blood types and proportions given in the table above define the probability distribution.
Yeah.
True?
I think so because they all add up to 1.
Okay, that's a very good point. Because we got 15 makes 60 and 40, yep. Okay, what is the probability that a random selected person in the United States has blood type O? So O is
0.45.
Yeah.
Okay.
Right.
So that is the answer?
Yeah,
Yeah.
0.45.
Okay.
Because we're not supposed to do it in the percentage, right?
Right.
What is the probability that a random selected person will not have O? So that will be 0.55.
Yeah. The opposite.
Okay. Carolyn Willis and her colleagues conducted a study in which dogs were trained to... Will you read this, Colton? I can't see it very good.
Yeah, you're fine. So it says Karen Wills and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrated the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. Answer the following questions. If the dog guesses at random, what is the probability that he will correctly identify the dish containing the specimen from the bladder cancer patient?
Okay, no, what? Okay.
So
Dogs trained. There were 6 bulbs.
7
bulbs, and 6 had that.
6 didn't have bladder cancer, and 1 had bladder cancer. So
They
I think
guessed
it's 1
random.
divided by 7.
Right, 1 out of 7. So, which is what?
That's
1 divided by 7 is 0.142.
3.
I'd say 3 because we're supposed
Yeah,
to round.
0.143. 0.143. Okay. In a combined trial of 54 trials, the dog correctly identified the specimen from the cancer patient 22 times out of 54. It is very unlikely the dog would do this well by random chance alone. Which of the following statements is most appropriate? This provides a strong evidence that dogs can detect bladder cancer, and this has little evidence. So it's probably a pretty strong evidence.
Yeah, I would say pretty strong because it's only 1 in
22
7
out of
chance.
54.
Yeah.
So that's like 41% of the time. So that's pretty...
Yeah.
Okay. Ken, do you want to read this one for us?
M&Ms are small chocolate candies. The M&Ms website previously indicated that in the United States, the distribution of the colors in a bag of plain M&Ms is given in the following table.
Okay.
If you reach into the bag of plain M&Ms, which is the probability of drawing a red-colored candy?
So 0.13?
Yeah.
0.13. What is the probability that random selected candy is green? So we have to add those up. 0.13 plus...
So 16%?
Yep, 16.
1.6. Interesting.
Okay.
And then,
Do you guys put 0 before stuff? I guess you do.
I do.
okay. I've been doing both.
Yeah, I kind of have to.
I don't think it matters because it's only the decimal place.
Okay.
Yeah.
What is the probability that a random selected candy is not green? So the opposite of that would we just added up is 0.18. I mean 84, right?
Yeah.
Okay. Okay, Colton, you want to do this one?
Yeah. The ACT scores of students admitted to a medium-sized public university in the western United States was taken from capexdocs.com. The following summary statistics were calculated. Use the information from the public university to answer the following questions. Half of the observations are less than or equal to what number?
Okay, what?
What?
Observations.
Half are...
Okay, admitted. Following summary statistics. Half of the observations are equal or less to what? Okay, so we go to the median.
Median. That's what
So
I'd say.
24.
That's the
24?
middle. Yeah, 24. That's what I'd say. Oh, this is from our last quiz, I guess.
Okay. Based on the information on the table above, the top 25% of the students scored above what number? So the top 25 would be in the...
75th percentile.
Do we have that information on here? Oh, Q3 right there.
Third, yeah.
Yeah.
So would be above 27?
Yeah.
Does that make sense?
Yeah, that makes sense to me.
Okay. Ken, do you want this one?
Yeah. Which of the following statements is not one of the 3 rules of probability? The third one.
Probability is high. Probability.
Properties, and it's probably one thing.
Probability negative. The second one is not.
Okay, I didn't read them all. Probability is 0, 1. Okay, the bottom one is true. The probability that an outcome will not occur is 1 minus the probability. Yes, that's true. The sum of the probabilities is 1. That's true.
Yeah, and if the
So it's gotta be
probabilities,
1.
yeah, because probabilities can't be negative. So 13 is not right.
Oh, yeah. So the very first one is the one we're gonna put, right?
Yes.
Well, okay. What is
No, the second one. The second one. It's not.
The sum of the probability. We must have, because mine says the sum of the probabilities on the second one is any probability is 1. I wonder if ours are different.
Yeah. Also, the wrong answer is if the probability is high, then the probability is positive.
Yeah.
If the probability is low, then the probability is negative.
Yeah, and that's the first one on mine. So
Okay.
That's
That's everything.
So do we feel comfortable with all our answers? Because I've been finding out that sometimes I just don't read them quite right.
Yeah. Based on the information in the table, the top 25% scored above one number. 27. Yeah, I think that's right. I think 11's right.
That's 84 and 16, and 13 that's easy. Bladder cancer, 0.143.
On number 4, I just
Yeah.
want to make sure that, so like when it says proportion, that's the same as the probability? Like,
Yeah.
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 okay. So we didn't have to do any math or anything?
No.
We just had to look at that one.
Okay.
Yeah.
All right.
I
And
think
then
those
we just
are.
had to do math on the next one just to kind of see what was left. And then, oh, wait. I might have typed that wrong. Number 5, I put .055. That's wrong.
It's 0.55.
Yeah.
Yeah, 0. I knew I would do something like that. Okay.
Mhm.
I think everything else looks okay, right?
Yeah.
Mhm.
Okay, should we try it?
Yeah.
Okay.
100.
Yay!
We did it right. Cool.
Good work, guys. So,
Yep. Wednesday at
Wednesday?
8 a.m. Yep.
Okay.
Sounds good.
See ya.
Okay, see ya.